You okay?
I will kindly ask you to close the door. Thank you, and good morning. I'm happy we are here together this morning. Hopefully the discussions will be quite lively and interesting for the last day of our forum. We've had competition before, but I do hope our topic will raise interest, because we will have to clarify a bit, I hope, issues related to technologies and innovation, green transition. I will briefly introduce the session to say that this is probably the most interesting period for anyone working in energy, with good and bad. We need adaptation. We have a framework launched 3 years ago already, the Green Deal, which comes with huge challenges. Unfortunately, since February 24, we are going through a crisis which, in our field, was reflected in a serious crisis of energy resources, and it impacted large systems and energy markets and so on. And it is clear, this is not only my opinion, the European Commission mentions this in the latest report for the Parliament and the Council on the follow-up of technological progress. More specifically, innovation is becoming a key element to close down all these gaps between what we knew energy meant and where we should get very quickly. 2030 already has more than ambitious targets. Within 1 year and a half, we moved from ambition from 40 to 45 in decarbonation. We have important targets to be set for energy efficiency. The world is moving on very fast. I will stop here, and please think of questions during the presentations delivered on different technological topics. The plan is that after the presentation, we will take a 45-minute Q&A session. Please agree this will happen at the end of the session, just to make sure we have control over time. I will now ask Mr. Curaj, Chair of Science and Innovation Policies, UNESCO. I will kindly ask him to help us understand what happens with innovation and where we should turn to. Mr. Curaj.
Thank you for inviting me. I'm really challenged to be here. I prepare my presentation in English, but having a translation, I will, if you are okay, you will see the presentation in English. I will deliver it in Romania. Is okay? Fine, super. Please allow me to put also the... Okay, it is, e prea mult să spun că este un keynote speech, nu e.
It is too much to call it a keynote speech. It's not. I tried to prepare an end-of-conference presentation. I'm sure during the conference we've seen interesting things with special and interesting discussions on technologies and innovation. And I will try to bring some color on this last session and raise some topics for discussion for participants. From this viewpoint, let's start. Again, this is a story about technologies. Some of them are directly connected to energy, others revolve around energy, but I do believe you will enjoy it. I have 4 points I would like to tackle. The first one is about digital transformation and sustainability. Second is about being prepared. Third, about smart energy systems. And I will tackle a topic I'm sure very challenging. I called it Mission 100, and I will detail later. And then some questions, maybe not for immediate answers, rather for future reflection. I don't want to take more than 20 minutes, ideally 15. Technology. Please accept that everything I say further is a combination between the person who is leading the agency, financing agency in Romania, and the perspective of a professor. We live in this world. We are connected. Everything is connected, and this is a specific picture. This is a tornado of changes, and they say that the digital transformation, of course, is fueled by digitization, augmentation, disintermediation, automation. These are challenges ahead of us. You are used, but it is important. We are in this fantastic area in the fourth industrial revolution, and what I believe important there is the reduction of borders between digital and biologic, and here we see lots of technologies, whether we wear them, we have them inserted, we interconnect. And in the session promo, I did see Industry 4.0. Within 10 years, this has been about digitization. I won't get into detail. I will disseminate the slides. Hopefully they are interesting for you. In Europe, we are discussing about this transformation of the European industry. We are accelerating production processes, and we are changing the role of workers in this game where everything is connected, but the world moves differently. The message now and the huge efforts are turning towards Industry 5.0, where beyond the digital we see challenges related to technology, of course, but the challenge is resilience, sustainability, and especially the human-centric approach. We have here the ingredients of Industry 5.0, and this will be a topic that will be a challenge for the second half of this decade, and we are looking towards Industry 6.0, and it's not only about numbers here, it's about technology, resilience, and everything connected. I will go through the slides. Obviously, Europe has this message. I am part of the European group who produced this report, and it's important that the forefront goes and is looking at science policies. If we are talking about 5.0, we are in the middle of 4.0. We don't forget it, and this is a very, very interesting report showing what happens with manufacturing now. In the report, you will see the report reflects what happens in highly developed, less developed, developing, and this ratio is very important. In the middle, we have the sustainability challenge. I just happen to be the head of the Sustainable Development Council at country level, trying to influence policies on sustainability, but we are not implementing. I like very much this report of the Rome group. Transformation is feasible, they say. There are feasibility scenarios. The report was published in 2018, but just like the pandemic around us, sometimes the elephant is right here in the room, and we don't know that, and we need to pay attention to such major surprises. And here we come with policies. I think it's very important to be able to look ahead in the horizon. In my area of expertise, we think on a longer term with immediate consequences. We say it's good to be short-sighted. You don't see very well at a distance, but you see what happens next to you, and you can look at technologies and be competitive. We are talking about prospective studies, but we are talking about risks. I like this report very much. If we look at the report and at the structure of our topics today, you see the metaverse, the blockchain, and very interesting, the major risks identified by the World Economic Forum. We are talking about digital transformation, this amazing rollout. We are part of the digital transformation, and eventually we need to look face to face and think, are we led by it, or are we leading this transformation? This is an important question which leads us here. If we understand where we are, then we can understand where we are going. Sometimes this is difficult to define, but this is our option coming from technologies and playing at the borders of technologies. My second point, being prepared. In technology, in innovation, the first message is I want to understand the trends. And when talking about trends, my metaphor is they are beautiful, but it's like when you are in a train station, very crowded, the train is full, and you are trying to hop in. Things are happening, and the chance to see a wow effect is low. When we speak of technological transfer, we need to think how we can understand those technologies, how we can absorb them, how we can develop them. But this is not where the major challenge is, where you can make a difference. It's interesting to see here there are 13 years since Deloitte, who is one of the sponsors. You should know, I did not know that. I just appreciate their report. So I chose here Trending the Trends, the 13-year history of trends, but not getting into details, just want to inspire discussions. There are other interesting reports on technological trends. I included them here, and when you receive the presentation, I'm sure you will be able to detail that. But beyond the trends, I need to scan the horizon and understand so that I can play either in the entrepreneurial area, in the area of innovation or destructive innovation. I like that, and I will. And how do you do that? We are talking about technology, using the technology, using big data, NLP, topic modeling, and things that help you develop something like a technological radar, which is not a story because stories are nice, but the reality makes a difference. The technological radar is being used across the EU in all important projects related to the technological frontier. We are trying every day to collect information, about 40,000 pieces of information every month. We are using AI machines. We are also using an intersubjective approach, and in the end we have few things that are brought up for discussion. We inform experts, we don't provide solutions, and here I have some elements, but since the story is beautiful but the reality makes a difference, a few years ago we did produce for the European Commission, together with our partners from Germany, Austria, Finland, a major document, still top document, 100 technologies that move the world, the Europe, at the 2025 horizon. We just look at things near horizon. I we'll give you an example. We are used with 3D printing. It's an interesting technology. It happens. What about 4D? The 4D printing technology, you are going to wonder, what does Courage want? Of course, for example, a simple thing. I take a device, printing 3D, I introduce it in my body, it does its job, and after a few hours it disintegrates, it disappears. There are lots of interesting applications. Just imagine what can happen when technology with borderline technology. These are interesting things, and I gave you here some examples. I saw robotics and machine interface from neuromorphic chips, bionics, brain functional mapping, lots of interesting things, but you can read the report. AI, robotics is similar. Very interestingly, cognitive computing, because of course artificial intelligence, fine, we are discussing about risks and ethics, but the difference is in the sophisticated part of the artificial intelligence that facilitates human intelligence. I come from robotics. For 15 years in a previous life, I've been a controller, and I know that the challenges then, and this is an amazing interface. I added here some things about cognitive computing as a connection to artificial intelligence.
Și v-am mai pus aici niște lucruri, v-am spus că scanăm permanent ce se întâmplă.
We are scanning what happens across the world. This is interesting news on human-robot interaction. I also have specific news we selected as interesting, but look, brain-inspired artificial intelligence. A certain type of chip is 1,000 times more effective. This is interesting. They do not exist yet. They exist in human mind and in experimental models, which are still far away from the market, but they can make the difference, because a possible startup in this field could be, at some point, something amazing. And I added here other interesting things. You see here a nuclear reactor, 3D printed nuclear reactor. Of course, this is experimental. This is in the lab, but we are talking about small reactors and Romania's experience. And I found it interesting. This is news. It happens there. So we are here. Can we benefit from it? Do we understand it before it becomes a trend? These are other things about solar chargers with hydrogen conversion. I try to give you examples at the crossroads of technologies, artificial intelligence, bioenergy. I think it's very interesting. Of course, we discuss how we can reduce the carbon footprint using artificial intelligence. You see here photosynthesis for hydrogen production. Of course, this is the frontier of frontiers, but it may lead to something, and what is today disruptive technology, tomorrow could become a trend. We have here the computing. On the list we had the metaverse, which is so versatile and interesting. I added the news we identified as interesting about hydrogen technologies, and, for example, nanotubes for graphene, energy-related, lots of wow technologies. Other interesting things. I found the last title interesting. Tokyo University uncovers solution to the problems of hydrogen fuel production. I will move on because I already had 15 minutes. I have 5 left. Another major technology is the blockchain. The blockchain technology, I used that chart. This is what the World Economic Forum says. The great advantage is that when you choose an area and click on it, the topic is interesting, but it's not the frontier, it's the limit between trend and novelty. And next, a very interesting report from Deloitte, and here we have blockchain challenges for energy. I'm not going to detail that. And I liked the look of the current energy market and how the blockchain here will influence the market, this market, in relation to trust. And eventually we are interconnected. The energy makes the difference. Society 5.0 is about the story of us in the middle of smart cities, of carbon neutral cities, interconnected with lots of devices, and the energy is vital. I loved this report in 2018 when McKinsey said about Romania that if we go business as usual, probably we will be able to reach 10% of the GDP in digitalization and IT. But if we are smart, we can get to 20 to 25% of the GDP contribution to of these fields. Here, Europe is very interesting. This green and digital transformation is very interesting, but I want to point out something. Europe has several major action lines, the mission areas at the center of the European research program. One of them is mature and very, very interesting. I chose it. It's here, the climate neutral and smart cities, and I will tell you that the 100 cities in Europe to pilot this challenge have already been selected. Romania has 3 representatives, and I would love to tell you about it, but we have something more. In Romania, we are the project leaders in the network. We participate in a huge European competition, 64 partners, all financing agencies in Europe. We are in the middle of things. We are talking about technologies, energies, and not only. Everything is there, and I hope we are going to be able to experiment. We have, by this I want to say, we have a huge chance. And he was speaking too fast, but not a problem. This is why usually I speak into English, because it's easier. I move on. European partnerships, and it's important to say here, clean mobility, hydrogen, there are others here and there, but everything is connected to what you do, and I believe that your role beyond the challenges of now is fantastic. This is our representation as financing agency in Europe, and we are present in various energy-related mechanisms, so look at us as financing agency to participate as partners with different European institutions. You have the presentation. I'm nearing the end of my speech. We are present, and that's good because we facilitate the presence of researchers and entrepreneurs in Romania in European projects, because partnerships are important. I already told you about the 100 climate neutral and smart cities. Soon you are going to hear we are building the mirror hub of this mechanism, because we need to stimulate not only the cities to assume the role, but also the technology. So you, school, research institutes, should produce technologies and absorb, manufacture interesting technologies for this challenge. The future is complex. I have here many important messages, and in the end, I have a few questions, more or less, to end. The first is, are we prepared? And you should know that for me, preparation means I like to be in the field. I don't like to be a taker, but a maker. And together we need to think what we can do together to break the barrier between policy taker and technology taker to technology and policy maker. Second, do we have sufficient space to experiment in Romania here? Or in our partnership, in our international partnerships, do we have the living labs where we can pilot the technology, and do we use them? Do we have sufficiently interesting demonstrators? I'm telling you, in Magurele, we have the most sophisticated pumps, heating pumps in Europe. This is where the bill has been paid already. But my question is, where is the energy mix? How can I produce their green hydrogen? How can I do things to ensure not only for the infrastructure, but to ensure for Magurele and the neighboring area positive energy, to become a positive energy district. Magurele is such a district in Europe. And next, do we have proper instruments? And here I am wondering, as a policy maker in research, do we have proper instruments to stimulate collaboration? And in the end, we are talking about ecosystems, but sometimes we cannot cooperate. Science ecosystems, innovation ecosystems, and I believe there we can make the difference. And if we can't bring close to us the entrepreneurial system, we won't be able to make a difference. In the end, I'm sure you know about Seneca. If you don't know what port you are sailing to, no wind is favorable. Thank you.
Da, în mod normal trebuie să comentez cum v-a prezentat.
Okay, normally I should make a comment on this presentation, and my first comment would be, wow. I was wondering, listening to this presentation and trying for a bit to stay in the area of energy, because this is our shared interest, since there was discussion certain time about multiple technologies on hydrogen. Hydrogen is a word that raises interest in one way or another as soon as you utter it. There are many in favor or against arguments, and trying to bring the discussion in a more pragmatic area. We have a clearly set target of not more than 30 days in a document which will basically become a programmatic document for the Europe of the next year, Repower E. And this document says that while until the Ukrainian crisis we had a very ambitious target of 5.6 tons or million tons of hydrogen, and to translate it into a more understandable quantity for energy people, depending on the mode of employment, meant between 10 and 20 billion of natural gas. Now we want to increase this number fourfold, and I won't call this green hydrogen, even though it's hydrogen without emissions, and this for a good reason, because this is also a debate that we would need to focus on later. That would help reduce the dependence on the Russian gas and to replace between 40 and 60 billions cubic meters of the 50 that we currently import. And for this reason, this topic goes beyond the hopes for solving it, and we are currently in the area of wondering how are we doing it. And I will invite Mrs. Karkadea, who is one of the people knowing the most about hydrogen. She's the head of the energy department in ICSI, Remnico Vâlcea, which is the Institute for Cryogenic and Isotopic Technologies. They are technological leaders in hydrogen area. Good afternoon, ladies and gentlemen. I think I can start my presentation by saying, wow, my mission is a difficult, if not impossible one, after Mr. Courage, but I will try to explain what innovation means from the point of view of our research institute, and I would say that it is the catalyst of the research activity. And I prepared for you some activities that we are currently carrying on in this direction to explain to you what we're doing and how we're trying to orient innovation towards technological transfer and obtaining some significant outcomes for hydrogen technology. ICSI Râmnicu Vâlcea is a research institute which was founded in 1970. It started with the technology to produce hard water. Starting with 1990, it changed directions because that technology was completed, and we have three important directions, and one of them is the one I am going to present today regarding renewable energies. Our aim is to promote excellence in fundamental and applicative research. And we started in 2009 by founding the fuel cylinders department. In 2012, we founded the low temperatures laboratories for support applications in technology. And in 2014, we founded a lab to store energy. In the bottom part of the slide, I tried to include our partnerships. In 2009, we became a full member of the Hydrogen Europe Research. In 2012, the Romanian Association for Hydrogen Energy was founded. In 2014, ICSI Energy became a national interest facility. In 2021, we became a founding member of Prahova with Hydrogen Association Excellence Center, and Mr. Administrator Vasile asked me to tell a few words at the end about this association. We have 5 research directions, and starting from the fundamental part of material development, and we have a group involving developing materials. Mr. Courage also talked about graphene, and we developed this kind of material both by chemical synthesis, but also by CND devices. We have integration of these materials in components, but I will explain this in detail later. We also developed 3 types of chemical devices, and there was a debate later whether there is cooperation between the hydrogen part and the battery part. Of course there is. We cannot develop an integrated system without having all these 3 types of chemical devices. And of course, we have the part of developing fixed and mobile applications. We have 2 main directions, one aiming at microtechnologies, and lately the part targeting technological transfer, which is important, specifically for transferring the results of research towards industry. We cannot stay in the phase in which the research results only remain in the lab. I want to insist on every slide regarding our accomplishments, but I only listed here some of the objectives that we had in order to give you an idea about what innovation meant for us, starting from material synthesis. And I was mentioning the graphenes, the co-catalysts with platinum content, and functionalized and non-functionalized graphenes, equipped with various materials, because our aim in research is, on the one hand, to reduce costs, and we're talking about chemical devices involving very expensive metals like platinum, like iridium, like ruthenium, and on the other hand, we want to increase performance and keep sustainability, and because if you have chemical devices without sustainability, those systems will not be feasible. You see here the system to produce membrane electrode assembly. We are starting from the material that we develop. We spray it by ultrasounding, pressing it, and checking the performance. Regarding the fuel battery development, we have a long history. We had projects dating to 2009 for developing fuel batteries. We start from the project design and the simulation stage to the system integration part, and you see here some examples and systems made in our research lab, and some educational systems for students coming to us to practice on them. And we also made some stationary systems. What is different for each of them? We tried for each application to see which is the optimal method to obtain hydrogen. For example, for this portable system that you see in the bottom left part, we have a reactor for producing hydrogen by hydrolysis of the sodium chloride with a maximum power of 250 watts. This was a result of a research project which was aimed at loading batteries for soldiers in tactical fields. So it was made together with the Defense Ministry. I heard that we will have here today a very detailed presentation from Siemens Energy, and we want to mention the part in our research institute dedicated to developing innovative membranes and catalysts for hydrogen and oxygen evolution reactions, and integrating them in complex systems. It is very difficult, for example, with personnel of 50 employees to be able to get to the next level, like in the case of important companies, Siemens Energy, for example. The technologies we develop technologies at the lab level, but the important part that we assume in this project is to also integrate electrochemical devices in commercial systems. And in this system that you can see in the bottom right part, peak power management unit, we have an integrated system with a fuel battery of 12.5 kilowatts, an alkaline device producing 200 cubic meters, and our aim is to elaborate the chemical management. So when we have renewable energy, the fuel battery will convert into hydrogen, and when we don't have the renewable energy, it will convert it into electricity. Regarding the program to develop lithium-ion battery, we have an integrated approach, and we can develop 3 types of cells with various chemical mixtures depending on application. Also, as I said earlier, we have an impact assessment part, environment impact assessment part, it is important to have a circular economy, to know how to use, but also to transform after use such electrochemical devices. And we have here some images from our line and the results that we obtained. Now, since during my presentation I included some applications like stationary applications, I wanted to include our mobile applications also in this slide, and you can see some mobile applications developed within our institute. In the bottom left part, we have 3 platforms developed. The middle one was developed during an experimental project using hydrogen. We have a Jeep platform with 33 kilowatts fuel batteries. We are currently in the phase of integrating the electrical part with the hydrogen using part and to develop the necessary energy management. I want to draw your attention, for example, to what we need. We need authorizations, we need legislation, and we need clear rules, because we're talking about hydrogen. People are reluctant, and besides the fact that we need to promote this new sector, new area, we need the authorities to support us and all factors, all stakeholders involved in this sector, in order to be able to step further towards technological transfer and further development of these systems. Coming back to innovation, I want to tell you that what you saw before meant for us innovation through 14 patents and 23 patent applications. We have over 20 projects that we started, and we're carrying out starting with 2020, Horizon, Meranet, Erasmus. We started this month one Erasmus project together with Polytechnica University in Bucharest. Also, Hydrogen Europe Research is a member in this project, and for the next 4 years we want to develop a curriculum for the hydrogen area. This would be a challenge for us, but also for the Polytechnica University and for all the companies involved in this project. From my point of view, I can say that we can transfer from the laboratory level to the semi-industrial level and even further. And I can tell you that since hydrogen technology was started to be widely discussed, we received some requests from small companies with some solar panels, small solar panels, until very big facilities who wanted to develop some feasibility and pre-feasibility studies to see how they can integrate hydrogen renewable energy into their processes. And we're currently working to prepare these feasibility studies, also taking into account the resilience program, which has a completion term of 29th of July for renewable energy. Now we can make the connection between research and practice. Now we are working for a project using structural funds, European Community funds, to produce fuel batteries and electrolyzers. The XRM Nicovolicea and other research institutes have also suggested a Romania hydrogen hub, and you can see an image of um, how we see this should look in Râmnicu Vâlcea, but each institute working this project will define their own infrastructure and potential. And I will come back to a question that Mr. Courage asked, how we can accomplish things together. From my point of view, we should have a top-bottom topic. So we shouldn't have 100 projects, for example, with wonderful results, but with different results, which cannot be transferred to practice. So from our point of view, this hydrogen hub could put together in a shared area, shared sector, all institutes, be them universities or companies or research institutes, to a common target. For example, something similar to the project of producing hard water that the Institute was part of, starting from 1970 until 1989. This was what I wanted to tell you. I also mentioned here something from the motto of our institute: research is what pushes humanity forward, and I firmly believe this, that research is the drive. Now, if you allow me to present for 1 minute the Prahova Association for Hydrogen. Mrs. Vasile, who is the administrator of the Vâlcea County Council, called me yesterday and asked me kindly to make a short presentation about her association. She's the founding member of this association, and you asked me why do we have two different associations. Just like the international level, there's a desire to create those hydrogen hubs. It is important to have involvement where in those specific areas in which we have significant results in hydrogen production areas or related areas, so that we can move forward. So the Excellence Center of Prahova Association has the founding members Prahova County, the Economic Research National Institute of the Romanian Academy, as well as the Oil and Gas University of Ploiești. Of course, we also have some management and administration and control supervision organs of this association. The General Assembly, whose president is Mrs. Vasile, the Management Council, the Scientific Council, the objectives, the aims of this association, and you can see that they are similar to what I said before. They want to develop technologies, installations and equipment for using hydrogen, both for transport and for producing electricity and thermal energy, which are critical for the Prahova County. I participated in a discussion about the challenges for the Prahova County, and this is where this discussion was started. They also want to develop technologies for producing hydrogen with zero emissions for covering the demand using renewable resources or other available resources. Technology transfer for producing and using hydrogen in various areas. Developing technology and technology transfer for recovering, storing and using hydrogen. We don't know how this will evolve in time, but we hope that we will also have research and innovation part, as well as the technical advisory part, economic analysis, for which the Economic Research Institute is the main coordinator, as well as some other related activities that could contribute somewhat or in a certain way to the objectives of this association. This is what I wanted to tell you. Thank you. I would highlight some ideas that form a connection, in my opinion, to the other debates. The fact that we need coordination to effectively use resources, more so in this area in which resources are so valuable. And secondly, that it is essential for the research and innovation part to reach the technological transfer and use stage in order to solve all the challenges that we currently face in the energy market. We should have continued online with Mr. Burkhard from Kinitz, who would have had to answer a question that I hope I will be able to ask by the end of this conference, when I hope we will manage to solve the connection issues. And therefore I will continue with Mr. Demetrescu, who is a partner to work forward in issues, and who will address an issue which is also very interesting, using a viewpoint that is mostly related to financial resources, project financing, and their profitability. Thank you very much. I am very happy to be here with you in this morning, although this is the last day of FOREN. I think that the audience is still interested. I also have a brief presentation, only to act as a guide for me. I don't think this was the one. I won't talk about that. I want to talk about energy storage, the grid level. What you saw until now from my colleagues, panel colleagues, were some truly innovative solutions, but if you analyzed a bit the figures and the measurement unit, you saw that the measurement unit was kilowatts. Now we're talking about the next level, which is megawatts, so 1,000 times more. Some considerations about energy storage, the grid level. We're talking about megawatts. Unfortunately, the solutions are few, and making them practical is hard, and financing them is a major challenge. First of all, we should look at the size of the projects and the technological availability of these projects. And thirdly, we should analyze the long-term storage, energy storage capacity. I tried to compare as far as possible the current storage systems, and for my presentation I compiled some data that I had about two very well-known systems, the battery system and the hydro pumping storage system. The battery system is newer. From the point of view of its size, it has a big disadvantage as compared to the hydro pumping system. The hydro pumping systems have been operational for more than 100 years. The first one of these systems has been commissioned in 1901 in Sweden and is still operational. The battery systems are easily exhausted. If you have a battery storage system of 2 megawatts, it will probably manage to bring to the network, to the grid, the current technology about 5 megawatts for 2 hours, and that's all. We have to reload it. While a hydro pumping system will be able to bring to the system the whole 100 megawatts that it accumulated, because this is the operational capacity of those turbines. The next thing that we need to analyze is the Capex. The Capex, or the investment size, the investment extent for such systems, battery storage, megawatt storage system. We need between 500,000 and 750,000 per megawatt. The pump storage system will cost about €1,200,000 per installed megawatt. The difference between them is, first of all, the lifespan of batteries is 20 years, while for the pumping system is about 50 years. And if we are, if we manage to restore them using half the initial capex, it will last for 50 more years. I don't think I will be able to live 100 years from now to see how the system will operate, and how it will be decommissioned after 100 years of operation, which will not happen, because this is how it's designed. Another difference between these systems is their technical yield. The batteries have a very good technical yield, about 98%, while a pump storage system has about 80% when their yield is close to optimal. Also, the environment and environment conservation. The only thing that I regret that you cannot see from my presentation is two pictures, one next to the other. One is a picture of a very beautiful lake in a very beautiful, very nice area, and the other one is a system somewhere in the field with some containers for storing energy. This is how it looks now, and how it will look in 10 or 20 years' time, depending what
Depending on what we want. Do we want a clean nature, maybe enrich nature with lakes, or have systems with lots of boxes and minerals, very expensive. We drill holes in the, and we bring that manufacturing plants and so on. We must speak now about regulatory constraints. The network code now says that any injection in the system should mean a fee. So we need to have a specific regulation for storage projects in the network. They do not produce and do not consume energy. They store energy. This is a new concept which was not present when the network code was designed. But we need to understand we have a new concept. We need to adjust the legislation and remove these overtaxation elements, which can only impede on the network functioning. A second and very important consideration would be the environmental constraints. What do we do with environmental constraints while... Okay, let's assume we changed the network code. Everything is fine. Now, as I said previously, a picture is worth 1,000 words. What do we do with a battery plant after the life cycle ended. What do? We remove the 100-ton materials, hopefully we recycle them. This is another problem. And then we bring in other tens and hundreds of tons of materials that will last maybe not 10 but 15, 20 years with technological advance, as we are encouraged by Professor Curaj. And everything should be considered. Now, I have talked enough about theoretical stories, and now I will give you practical examples. Recently, together with my partners in Germany, we finalized a feasibility study in a gas plant in a combined cycle with the two gas turbines summing up 100 megawatts installed power in order to bring in hydrogen and burn 10% hydrogen in combination, because the turbines are operating. To burn 10% hydrogen in these turbines, we need to install, take a seat, deep breath, we need to install 1 gigawatt of solar panels to produce green hydrogen. This is the conversion rate, 1 gigawatt photovoltaic plant to produce the 10% hydrogen needs to reduce emissions. Okay, deep breath. This is the technological reality today. I know you are disappointed after the beautiful speech of innovation and research. My colleagues were talking about kilowatts, and we did not speak of costs. I'm talking about megawatts, and I'm thinking of costs, because in the end, yes, we have European funds, but we also need funding, and our investors look at numbers, and then they come up and say, what is the rate of return in your project? I compared technologies, and I can say honestly that for batteries the IRR is towards 0 to negative, and use that grid parity as a standalone project without coupling it with anything else. I want to have a storage plant I can play with and provide that energy, the settlement and energy in the market. I buy cheap, and with a financial modeling, the hydrogen is completely out of question. It has a huge IRR now with our technology now, and for pump storage, IRR is 12-15% today, with the figures and the calculations I made with my colleagues. Now, if we want to open up this road, indeed, the figure reality will move the projects forward and will help us decide, do we implement the project or not? If we can finance the project, we do it. If not, it will remain at an experimental level. Let's see how the technology works. Let's see at a lower scale, and then extend to a macro scale so that it is financially efficient as well. Because right now, indeed, we need innovation a lot. We need energy a lot, especially green energy in Europe, because we set very ambitious decarbonation targets in Europe and across the world, but we need to take steps towards such targets. Something I would like to get back to is the implementation duration. A battery storage project can be implemented within about 1 year after getting all permits and licenses, and a pump storage hydro project at least 5 years. A hydrogen project probably about 2 years at this grid scale parity. With hydrogen, we have another problem. if we don't consume it when it is produced, I need additional storage space. I need to store it, high pressures. I also need power consumption to maintain that pressure. It depends on how or we are going to use the hydrogen further. I just wanted to give you an overview on the funding of such systems. We need to understand that we have to go there. We need to have such storage systems. I did not speak about the thermal storage system. It's very interesting. It's much easier to create, to implement, and it's much more profitable if we manage the plants, pump heating plants. But I will not detail this now. Thank you. Hopefully I was not boring, even without visual help. Thank you. I'm happy we started debates. I have one comment from a personal perspective, but I think we need to consider this. Everything I knew about business cases until 3 months ago, I think we can forget it. This reality with the gas price, which very likely will be about around 100 euro per megawatt for 2 or 3 years, and I hope I'm optimistic for 2 or 3 years. That changes the logic of many business cases in technologies. And second, we are going to face another problem at European level, not in Romania. Romania has a special situation. There are two countries which may rely on natural gas resources in Europe, but all others, many, they have a problem with the 155 billion cubic meters we want to give up. And this is a problem on the table. We need this debate because obviously we are looking at the period where many things we knew about reasonably economic solutions are changing. Let's continue on the same logic with storage. I'd like to invite Mr. Daniel Mares, a senior sales account manager with Honeywell Process Romania. His presentation will take us a bit further towards storage technology details. Hopefully we will find at least some answers to the many problems raised by the storage and still stick to the basic idea. Storage is a problem that must be solved if we want resilience, stability and balancing, if we want integration, if we want to get to energy systems that will have to make for 55 possible. Hello and thank you for inviting me. I come in a more complicated moment after Mr. Demetrescu, who gradually, well, we could not see it actually, but he tried to show us that batteries would not be a solution in terms of energy storage. I'm here to show you precisely the opposite, and I hope I will be able to prove this. I'm glad. I am glad because I have even more power because he raised the issue for me. So I work for Honeywell. The slides, I apologize, are in English because usually we are using English, but this time I will speak Romanian. I just wanted to show you here very briefly, Honeywell has invested a lot in sustainability. All figures here, about 90% reduction in greenhouse gas. 3,000 acres, well, 4,000 square meters remediated soil projects currently being implemented in 5,700 projects. So I wanted to show you that customers are very important for us, but we are trying to set a trend and show the market that we actually can do it internally. Honeywell is a global company present in almost every country in the world, and in terms of factories and production installations, we have about 1,000 installations. So we have experience in industry in our viewpoint, first of all. And second, we are experienced in helping our customers to go towards sustainability and greenhouse gas reduction. I wanted this picture because we are talking about green energy. Even though we are speaking of batteries, our goal, our ultimate goal is to produce green energy and to store this energy. So my slide is called Sustainable Technology Solutions. Honeywell has had intense activities in different fields on sustainability. Batteries would be only one field, which I am going to detail now. But in our viewpoint, when we look at renewables fuel, we look at sustainable aviation fuel. We already have tests performed in the USA with a large company to use our SAF production system, which has already been developed. It was tested 5 months ago. Probably it will go into production at global level probably in 2 years. There are different companies interested. Again, plastics circularity. It's difficult to translate it accurately in Romanian. I will use the English terms. The hydrogen I will not tackle today because there are already too many speakers on this topic, so I will not step towards hydrogen, but we are looking, as a company, we are looking very carefully at hydrogen. We developed solutions for hydrogen. I will not insist now. The carbon capture, I think this has not been tackled too much. Similarly, it is connected to the sustainability trend. Similarly, I will not go into details. I just wanted to show you a panel of solutions for sustainability today with a focus on energy storage. Very briefly, there are lots of figures and information in the slide. Honeywell, in the past 4 years, Honeywell has invested lots of resources in research and development on energy storage. Right now, with lithium-ion batteries, LFP chemistry, the lithium-ion batteries, as we all know. The storage time is limited right now. We are talking between 1 to 4 hours. What we did, step forward, we are looking at non-lithium-ion solutions. It's a solution developed by Honeywell, currently under a testing period. My point is that Honeywell is involved from feasibility study until the end of each project. We are partners with our customers. We start with the feasibility study to see whether an energy storage system is actually needed, to see the costs. Here I will contradict Mr. Demetrescu because in terms of costs, right now the amount he mentioned, 700,000, is a bit too much. This was in the market, I think, 6 or 7 years ago. Right now we are talking somewhere between 300,000, 400,000 euro for a system. Because I don't want to insist a lot on lithium-ion batteries, I want to show you our storage unit. This energy storage system is developed by Honeywell. We are not using external partners here. In cabinet, we are using standard cabinets, 20 feet or 40 feet, to enable maritime transport because we have global customers. We used the Honeywell research and development, and we managed to integrate within one container, 20 feet in our example. We can reach 4.9 megawatts per hour usable energy, depending on the use. But very quickly, I wanted to show you the energy storage system we have inside the DC, the AC, battery racks, and HVAC units, which are very important. I think Mr. Demetrescu, I'm sorry, I keep getting back to you. He mentioned these systems are not energy consuming. Well, they are when they are not used. They do not export or to the grid or import from the grid. They consume power because the ventilation systems must be operational at all times. The second part of the Honeywell investment in battery storage is the energy management system. Here, we invested following the experience we have in the market. We have been active in the oil and gas market for 40 or 50 years, and I believe that 50% of worldwide refineries are using Honeywell command systems, so it was easy for us to go to energy management using the same equipment, the same software platform developed for oil and gas. We are now using it for energy. The command system used by the entire battery storage trend is this EMS. You see it in the middle? It's a PLC, more precisely an RTU. I think the smallest PLC in the Honeywell family, which enables us to ensure all the command part for the system, storage, auxiliary, FOREN gas, and so on. And the microgrid, more specifically, the use of this storage capacity for different applications. The energy controls, I apologize, I need water.
Scuze încă o dată.
Sorry. So the energy control part, we took the next step already to control at the same time several units which are distributed geographically in different countries, even different continents. Right now we have a customer with storage units both in Asia and in the America, and our system enables the customer to control and monitor them from the same location in the USA, although they are on different continents. So, the applications, I will try not to translate because in Romanian it will not sound good. So it's from peak shaving. Everyone knows what peak shaving is, capacity firming, which is an app which enables the integration of green systems, as I mentioned earlier. Wind, solar, their integration in existing grids comes with a major problem, an imbalance which occurs because all these energy production solutions are intermittent. They don't produce permanently or at the same values, so we can use an energy storage systems which enables the regulation of energy export to the grid. Then we have the frequency regulation, the VAR support, and then frequency regulation. Frequency regulation is a hot topic for all operators across every Central European country, because frequency regulation now is performed using old systems, 30, 40-year-old systems. Now they are looking for solutions to use lithium-ion systems for the country operators, the so-called TSO. The virtual power plants, as I mentioned earlier, these are customers who have storage systems and wind farms and solar farms across Europe, and they want to monitor and control them from the same point, regardless where in the world. So this is why we have the virtual power plant. We did not invent this. It's a term from the energy industry. We took it over and we demonstrated we can build such a virtual power plants regardless the customer location or the asset location in one system which is connected to the cloud. Using this system, they can command and perform remote maintenance for these storage systems and for these wind farms and solar systems. And now it gets interesting. To again contradict Mr. Demetrescu and what he said about batteries. It's about redox flow. Battery energy storage technology is a complete shift compared to the minerals we are talking about, and the logistic chain part, which for some months has become very complicated. This is a part of the Honeywell research and development. It's an invention patented by Honeywell. Currently, it is not available commercially. I just wanted to present it, to briefly introduce it, because it's an upcoming technology. We invested a lot in this technology, and right now it helps especially energy operators, because the storage capacity and the storage time are much higher than in the case of the standard storage systems, lithium-ion or any other technology using minerals. I don't have an end slide. Actually, my end slide is an invitation. I wanted to present in a few words a project we are currently implementing in Romania, more specifically in a Honeywell plant in Lugoj. As I mentioned, Honeywell invests a lot in sustainability. So right now we are implementing a project in our Lugoj plant, which will include solar panels and 1.2 megawatts per hour storage system, and the entire part of energy control from in the factory, in the plant. The system will become operational in October or November this year, so you will be able to see it live. The factory, the plant will be open to customers or potential Honeywell customers. If you are interested, you can contact us and we can visit the plant to see concretely how the system looks like. Thank you very much.
Noi mulțumim. Aș remarca faptul că
Thank you very much.
ultima prezentare vorbim deja.
If we look at the last presentation, when we speak of battery storage, we are talking about at least two large families. If we look at other scientific articles, it seems there are at least 7 types of technologies. Each of them would have different applications. This is an universe in itself, because if we add to this the long-term hydrogen storage problem, which is a serious topic, if we think of the challenges we are going to have with solar developments, we're talking about 400 gigawatts in Europe by 2030, and the fact that we will have PV production peaks which will have to be used, then we start to understand how complicated the storage topic is. I will now move towards an area which is just as interesting, the heating pump technology. With two figures, we want to install by 2030 30 million heat pumps. Germany recently announced a plan to install, starting with 2025, I think, at least 1 million heating pumps per year. And I will stop here. I will invite Mr. Klimt, who is director with Siemens Energy, to deliver his short presentation on the topic. The presentation will be in English. If necessary, you may take translation devices. They are available. So, Mr. Klimt, please.
Unfortunately, I need to speak in English today because I recently relocated to Romania in February this year, and I'm still learning the language. So therefore, please allow me to do my presentation in English. Before you see the slides, and I hope the slides will show up soon, a few words about me. So I'm with Siemens Energy already almost 25 years. And you know, especially in the energy sector, we see a huge change in the environment, so coming from the fossil fuel-based power plants, the big ones, the utility ones, going more into the green power plants, into more decarbonized power generation, and also going more into the decentralized power generation. This is really a trend we see, and you don't have it? Oh, okay. That's a small problem. We can solve it right now, just one second. I can also give you a speech.
Eu sunt Petru.
Hello, my name is Petru Rușeț. I'm a management director at Siemens Energy. Wolfgang was very modest and didn't mention that he would manage an excellence center in Romania, which we will grow to a large extent. We target 2,000 employees in the near future. Wolfgang.
Mai sunt situații
If there are any other situations in which you have presentations, please send them by email or using a flash drive.
Bit about decarbonization of the industry with special focus on industrial heat pumps. As you know, we have at Siemens Energy, of course, also the hydrogen production, the so-called Sealyzer product. We have also battery storage systems, so similar to that what we saw already today. Nevertheless, I would like to focus today on the industrial heat pumps and the decarbonization of the industry. What you see here on my first slide is a little bit an idea what is the contribution of the industry towards, first of all, the energy consumption, but also towards CO2 emissions. You see on the left side, the industry consumes roughly 30% of the total energy consumption worldwide. On the other hand side, we see as well a CO2 content of roughly 40% coming out of the industry. And if we then go and divide the industry CO2 emissions into different applications, then you see that The heat production in the industry is roughly 40% or even a little bit more than 40% of the overall CO2 emissions. So this is basically one of the levers we have to do decarbonization in the industry, to tackle these heat production and have different options in the heat production. And the levers we have, of course, is first of all efficiency increase. This is obvious. On the other hand side, replacing fuels. And the last days we heard a lot about hydrogen. Of course, hydrogen is here as well, one lever to decarbonize the industry, to replacing the fuels from fossil fuels to hydrogen or any other green fuels. And on the other hand side, we can also try to use a green energy to produce the heat. And what you see here on the next slide is a little bit the different applications, different temperature levels which is needed in industry. And here I'm speaking really only about industry without power production. That's real industrial applications, industrial sectors. And basically they have different temperature requirements. And this you see here on that chart in the middle. And all the heating and cooling applications in the industry is basically divided in temperature levels. Of course, we have very high temperature levels. If you, for example, use the cement industry with a rotary kiln, we use normally coal to heat up that above 1,000 degrees to produce the clinker. So this, of course, cannot be done with any other electrical stuff. There we need still fuel, and there we need to change the fuel, for example, to hydrogen or any other green fuels. This is one possibility on that high temperature heat sector. The other possibility is, of course, to add carbon capture, utilization, and storage systems. But if we go more into the lower temperature part, and although there in industry we see a lot of applications where we do not need such high temperature levels, then we can change the heat production from fossil fuel, which is currently the basis, to more electrical-based heat production, for example, electrical heaters for the higher temperature range. And also we as Siemens Energy working on that one, replacing boilers, fired boilers into electrical boilers. So this is also one application we have, and we are working on. On the other hand side, if we go more into the lower range, then you see we can apply the heat pumps. Yeah? And heat pumps has basically, we divide that in two different parts. One is the low temperature heat pumps, which are going roughly to 100 Celsius. And then we have the so-called high temperature heat pumps going more into the direction of 150 Celsius nowadays. And the innovation should be, of course, going more into temperature, so going up with the temperature level. One topic I would also like to mention here is what you see on the left top box. You see the waste heat recovery. And this is a potential we currently have worldwide, which is more or less untapped. Only to give you an idea, a favor, and the number. Worldwide, we have currently roughly 5,000 terawatt hour of untapped waste heat going currently to the atmosphere. And if we do some pessimistic assumptions and estimations, then we can add, based on that one, roughly 20 gigawatt of power production facilities to all that waste heat sources, which is roughly 170 terawatt hours every year we can produce without additional fuel, only using the waste heat which is currently wasted to the atmosphere. And then this is also one topic I do not really see if we look to the European Union and the Commission. We look to hydrogen, we look to everything, more or less into the R&D development topics, but the current potential which we really have is mainly untapped. And there, I hope we will see in the next couple of years also movement there, because there are also plans, of course, in place, but as said, it's currently more or less untapped. Okay, going now a little bit to heat pumps. What is the heat pump? Very principle, the heat pump works. We need a so-called heat source on a lower temperature level. We put that into a heat pump. In addition, we need energy, electrical energy or mechanical energy to drive the compressor of the heat pump. And then the output is high qualified heat, so on the higher temperature level. And this you can see here on the right side with the main components, how that really works. We have the heat source, which is really on the low temperature level. This is used in the so-called evaporator to evaporate the fluid of the heat pump, normally refrigerants. And then going into the compressor to a higher pressure, including as well increasing the temperature level of the fluid, which can then be used in the condenser to heat up the second cycle of the heat pump. And then going back via the expansion valve to the evaporator, and the cycle is closed. This is the working principle of a heat pump, and the efficiency of a heat pump system is defined with a so-called COP, coefficient of performance, and you see here the definition. So basically it's the thermal energy I can get out of the heat pump divided by the energy I put into the heat pump. We at Siemens Energy have, I mentioned that already, two product types or product lines. One is the high temperature heat pump you see on the left top box. This is a heat pump right now which is more or less unique on the market, and you see that on the next slide, where we can produce temperature up to roughly 150 Celsius as output temperature of the heat pump. And you see as well the power, though we are speaking really about industrial heat pumps. Our heat pumps are more for the large scales, starting from 5 megawatt thermal output, going up to 70 megawatt thermal output with a single heat pump. And then on the bottom part, you see our so-called low temperature heat pump. And this one is going up to roughly 100 Celsius, so mainly for district heating applications. And this is a little bit smaller one, up to roughly 45 megawatt with a single heat pump. If we now look to that chart here, what you see on the left side of the slide, this is what I meant earlier, though we have currently a unique situation on the market. Our heat pump, the high temperature one, is going to 150 Celsius, which is more or less unique. You see on the left side of this chart the competition. So most of the competition having smaller heat pumps in terms of heat output, but also lower temperatures going in the range of 100, maximum 120 Celsius. And what we can also do, and what we have also done, and we are working on project already on that one, we can use in our heat pump, or we can produce in our heat pump low pressure steam, and adding then a steam compression system, a compressor basically, to increase further the pressure and the temperature, so we can also produce really, based on electrical or mechanical energy, a high qualified steam for industry applications. At the end of my presentation, I would like to give you a little bit two small insights into projects. So we are really working on projects, so that's not an innovation, that's already real. Though we have, for the low temperature heat pump, this project in execution right now. It's in Germany, it's in Mannheim. For the so-called GKM, stands for Utility Power Plant. This is currently the power plant in Mannheim producing power, but also heat for the district heating. And there we apply the first heat pump as a test case to see whether we can substitute the coal-fired plant via heat pumps to produce the heat for the district heating system. And the idea of Mannheim is really to go into the large scale, so adding a lot of more heat pumps to completely shut down the coal-fired plant. This is one example, so basically using a heat pump and using the electrical energy for district heating. And the other example is even more interesting. This is a very small one, so we have speaking here about only 8 megawatt thermal power output. This is in Berlin for Vattenfall, the case, and there we are combining basically the district cooling and the district heating networks. So the source of the heat pump is a district cooling, so we cool down the district cooling system with the heat pump, and using that low temperature energy to produce high temperature heat for the district heating network. So this is really an application which is more or less unique, I would say, on the market, and it's a test case, but you see, and we can do a lot with heat pumps and we see also a lot of interest in the markets, especially for district heating applications. Yeah, also in the fact that, you know, in Germany we closed down all the coal-fired power plants. This is decided already, and for that we need something to replace. And heat pumps can be one lever to replace the coal-fired power plants for district heating applications. That was my last slide. Thank you very much. Mulțumesc.
Thank you. Situation and having in Romania, I think, more than 1 million boilers, individual boilers installed. Heat pump technology, at least if we see the same ratio between the price of the megawatt in gas and the one in electricity, which is almost parity, I think this technology becomes one that will somehow blow up in the next year, simply because economically speaking, is the best moment to start replacing the fossil fuel, at least in individual boilers heat. Obviously, you have some advantages that I am seeing at my home. I installed 11 years ago a heat pump. For sure, it's not the most efficient one, but I can assure you that you can already see the benefits shifting from gas to heat pumps. That being said, I would move, sorry, I stay to English. Deci asta fiind spuse,
this being said, I will change the direction to an area which is just as interesting, electro mobility. We have two speakers, Mrs. Elena Manta from Siemens Energy, Romania. Sorry, I didn't get used to it yet. It's Siemens, not Siemens Energy. The difference is important. Mr. Dumitrescu wanted to say something. I wanted to add to what you said. The individual systems are not yet taxed for CO2 emissions, which could make a difference in our decision to shift from gas units to heat pumps. Yeah, this is a debate based on the proposal for energy taxation directive. They will not be taxed in the future. It's very hard to tax 1 million users. They will have a tenth of the taxation used for any other application than heating, but the gas price, electricity price ratio is sufficient, in my opinion, and I think we all have we have all the economic reasons in the market to have a serious look at the energy. So I invite Mrs. Elena Manta with a presentation on electromobility. This is a very interesting topic. Europe in the latest years has almost reached parity with China for electric vehicles. Last year, China, which was the traditional leader in electric vehicles, has reached 3.5 million. Of course, we're talking about light vehicles, and Europe is close to 2.5 million. They are by far the leaders for electrical mobility, and electrical mobility, as we will see in 2 presentations, and I'm convinced that the colleagues in the hall, especially those working in distribution, will have something to say. Okay, please, Ms. Manta. Thank you. My name is Electro Manta. I represent the Siemens company. We create a lot of confusion with this reorganization in the Siemens group. Okay, so I'm part of the Siemens Germany headquarters team, which develops the products related to electromobility. In the following minutes, I would like to bring to your attention the way in which Siemens wants to create impact in this landscape of electromobility and of a sustainable future for all of us by developing a portfolio in the electrification area and charging network for this electromobility topic. I first of all want to remind you about the trends and then a brief summary of the Siemens portfolio for e-mobility, focusing on products and services, and at the end I will mention a reference project of Siemens. As I said, everyone is aware of the mega trends that we are facing. These are very deep structural changes. Starting from climatic changes, there is a trend of globalization, a trend of urbanization. We actually face a demographic profile change of our population, and last but not least, following the global events, we had to face this physical distancing, and this physical distancing highlighted a need for flexibility, for high flexibility, for some business models that would allow for flexibility, business models that maybe accelerated a bit the advance of this digitalization component. Looking at the future, but not only the future, but also the current days for the transport of for the personal transport and merchandise transport, freight transport, there is an increase in using electrical vehicles. There are some clear needs to ensure greenhouse gas emission reductions and decarbonization. So after the United States, also the European Union comes with some clear targets until 2050. And more than that, in the European Union, there are countries which set their own targets like zero CO2 emissions by 2050. As I said, this population migration in the urban area actually changes the transport model by developing the public transportation area and more than that, the electrical public transportation. More and more producers, manufacturers for the public transport, but also for heavy transport or truck transport have said that they want to increase their percentage of electrical vehicle production. There are there are manufacturers who went from producing a few pilot vehicles to a clear target of more electrical vehicles being produced. So e-mobility is transforming our everyday life. We see a lot of applications around us, not only at the global level, but also here in Romania. There are multiple applications, and if we are to see a common trend of this application, this is diversity. Actually, each player in this market comes with a different business, a different need, and different motivation. While a supermarket may be only interested in attracting a certain category of customers. A company which is active in the residential area of or building business spaces may be interested also in ensuring maintenance services, while garage chain will be interested in not having its activity affected by this new business model. So integrating these solutions and the electromobility area is a challenge, and Siemens is a partner having a complete solution, end-to-end solution for this challenge. We have a complete portfolio for the entire period of carrying out such a project, starting with defining the business model to implementation and operation. Basically, a smart planning is very important because, as I said, there are various business cases. There are different questions. Some players in the markets may ask, how many chargers should I install? Where should I install them? If they have distribution stations, I may wonder what is the impact that these stations may have in my business. So as a distribution utility, I should pay a lot of attention on how the consumption will increase, because a distribution operator fails to realize where consumption peaks will be, and it should be very attentive, very careful in order to prevent future congestions and to make smart investments. Siemens is based on an experience of decades in this area of planning and maintenance. More than that, we are also communication point operators for our own network, but also the networks of external customers. In this end-to-end solution, we also bring a portfolio of hardware products covering wide range, like high power solutions and fast charging solutions with continuous direct current feeding, but also a portfolio of connected services. Actually, Siemens is coming in this e-mobility landscape with a modern portfolio which is adapted to future needs, responding to client needs, to legislation, to the need for standardization in this area. I have a presentation which has multiple slides in one, and this remote doesn't help me, so I will move to the next slide. As a portfolio, our first range is the range of Versi Charge products. This uses alternating current. It has an intuitive design dedicated to residential applications, but it is used also for public or semi-public applications like parking lots, like commercial parking. It has high adaptability. It can be supplied for single-phase or three-phase applications. The product of the future, as we see it here in Siemens, is the C-Charge D product, high power, flexible, modular and scalable product, which Siemens is developing for urban applications, but also for long roads, for highway charging, for example. It is available as a compact solution, but it can also be extended, upgrading the power up to 300 kilowatts DC. This power is distributed by two supply possibilities in DC and one in AC up to 22 kilowatts. Starting with August, the product will also have a dispenser which will allow parallel charging of up to 5 vehicles. So we will have the 3 supplies starting directly from the charger, and will be distributed among the 2 dispensers. And for the electric fleets, our solution is the product family called C-Charge UC. This is a product family. This is more than a charging solution. It is like a charging system with both a compact solution for 100-200 kilowatts with direct cable feeding of the vehicle, and up to complex charging stations with the same possibility of extending the charger with 2 dispensers, but also with charging solutions over the course of an electrical bus, for example, with using the pantograph of the buses. This is a high power solution starting with 100 kilowatts up to even 600, 700 kilowatts, under development at the moment. As I said, Siemens has a complete end-to-end solution for this e-mobility challenge. Siemens actually can ensure the hardware portfolio, complete portfolio, from the connection point to the grid with low, medium voltage equipment, including integrating renewable and energy from renewable sources, but also storage systems, also in Siemens portfolio, but and metering solutions, while using external solutions for invoicing, for example. Getting to the service portfolio, as I said, which is connected to this e-mobility portfolio, we have a modular approach so that our customers could choose any element they may choose, they may desire, and they may find fit for their business models. And that's the spine. The main point are the digital services, and I have to mention that the peculiarity of these products is the fact that they allow for remote connection. So in this way, technical support can be available for these products from the commissioning phase, from the configuration phase, which could be made remotely, continuing with data monitoring for this charger, aggregating them, analyzing, report preparation, until remote troubleshooting, even firmware update can be made over the air. When there is an incident that cannot be solved remotely, of course, we have all the classical services portfolio, and we can offer site visits for all kinds of preventive, corrective maintenance. because these products are adapted to the needs of the future, and the powers will increase more in the future. As I said, the portfolio is a modular one, and it allows each customer to create their own puzzle with this central point of digital services. Of course, like for the hardware area, the Siemens can offer an end-to-end solution also for the services area. Our customers can receive performance indicators for the operation of this charging infrastructure, and we can offer service level agreements starting from the grid connection point with the entire electrical portfolio of Siemens until the charging point.
La ceea ce ar fi trebuit să fie un slide, un ultim slide.
This should be the last slide and bring to your attention just one reference given the short time available. Siemens provided the entire charging infrastructure for a transport operator in Hamburger Hochbahn, and actually delivered the entire installation from low voltage equipment to medium voltage equipment, including 96 or per 6 charge UC200, and basically electrified 2 of the 6 car ports of Hamburger Hochbahn. Currently, the project has been finalized in terms of delivery, but there is a service contract, a 5-year service contract with the operator. After this brief presentation, I would like us to remember at least this idea. Siemens is the ideal partner for any customer. We want, as I mentioned earlier, we want to have an impact on a sustainable future. We have a qualified, dedicated and experienced team of professionals, including in Romania, and we work with our customers to develop the necessary and flexible solutions for our customers so that they may focus on their business and to create a competitive advantage for our customers. Thank you. This was my presentation. Thank you. Lots of interesting things. I would now say that the planning of this large urban agglomeration network would enter a different logic than expected, and probably not only that, this will not be the only massive challenge in terms of electric vehicles. Now I will ask Mr. Burgis, my former colleague from FOREN, Romania, but although it's unfair for the latest presenters, please do not exceed 50 minutes because there is no more time left for Q&A. And in the end, Mr. Râmbu will help us get an overview of all technologies we are looking at from a green transition perspective. Then we will have a Q&A session. Hopefully we will have more time. Do we have any other event afterwards? Good news. So if you are willing, there is no other event in this room immediately, so we are not very limited with time. Thank you, Cătălin. Thank you for inviting me. It's an honor for me to be part of this panel. And I would like to remind you one thing. Besides battery storage and hydro pump storage, we have the cement block storage, which is an emerging technology, although not just beautiful as an artificial lake or just as small as batteries. However, this is a viable alternative. Together we are going to look at e-mobility and investments so that this e-mobility ecosystem may operate properly. Of course, besides e-mobility in the EU, I think Germany is the largest market, we see fuel cell fueled vehicles. As a main driver of e-mobility, we have various legislative packages in the EU, Fit for 55, Repower, European Mobility Strategy, and so on. They all have the goal to accelerate the adoption of alternative mobility, especially e-mobility. Besides these packages already in place, we have different municipalities which have already taken action and defined the so-called low emission areas, low carbon emission areas, or zero carbon emission areas, where the access of vehicles with internal combustion is banned, and in the low emissions zone their access is only permitted in certain conditions. Of course, with the wide scale adoption of e-mobility, we also face barriers. First of all, the customer concerns. What worries our customers? And here we can mention the charging infrastructure, the charging duration, lack of availability, the limited driving range with an electric car, and the very high vehicle price compared with internal combustion engines. Moreover, we have a raw material crisis. We have a supply chain which has been disturbed after the COVID pandemic and the Ukraine events, and everything means additional pressure on the EU and on Romania to follow the path towards e-mobility. In the EU, there are different e-mobility development scenarios. And the European Commission forecasted that by 2030 there should be about 33 million purely electric vehicles in the EU. Then ACE made a comparison to see what is the number of electric cars and charging points we need in Europe. And the conclusion is that by 2030 we should have about 39 million electric cars on European roads. Starting from here, keeping a ratio of 10 electric cars per public charging point, both the European Commission and ACEA reached such a ratio, but ACEA used a ratio of 6 electric vehicles per charging point. So we will have anywhere between 2.8 and 6 million public charging points by 2030. But that means financial effort for the EU and member states, about 196 billion euro, as estimated by ACEA, and most of such investment would not go to the power grid, but to the charging points, about 18 billion euro to have alternative green mobility. We need to think and have in place renewables capacities, and here we need the investments of about 69 billion euro in the EU by 2030. Now, to realize the extent of these amounts, I would say that investments in charging points are only 18% from the investments planned for the 5G network. Grid investments are only 14% of the investment forecasted by 2030 to modernize electricity grids, and investments in renewables account for about 20% of the investments forecasted by the EU to ensure the energy transition according to the Fit for 55 package. In Romania, what did we do? We tried to measure the necessary investments for Romania in this transition towards e-mobility and e-cars. We have here two scenarios which lead to about 300,000 vehicles, electric vehicles. Getting back, all these investments, 196 billion euro, would lead, as a ratio of electric car, would reach from 1% today in the EU to 12 to 14%. So that's a huge financial effort just to reach 12-14% purely electric mobility. Getting back to Romania, these 300,000 purely electric cars should be charged by 30,000 public charging points, or 50,000 according to estimates, to reach the ambitions in the Fit for 55 package and reduce transport emissions. We tried to measure in money, and the conclusion is about 1.4 billion euro we need in Romania to implement a functional ecosystem of e-mobility. Most of the money would go to investments in charging points, followed by renewable capacities to have a truly green mobility, or at least greener than if we would be using the grid powered. And then we have the grid investments. Here, they are mainly related to the distribution grid and to strengthening the grid and to upgrade, transformers upgrade. All these are very important. Without them, I don't believe we can have a proper deployment of the charging points. This 1.4 billion, we need to bear in mind that in our viewpoint will not lead to a market increase at the pace expected by the two scenarios. We also need AFM funds, which are an important incentive for the e-mobility market in Romania, because 2/3 of the new electric cars purchased are purchased using AFM grants. At the 2030 horizon, they will place additional pressure on the national budget, about 3 billion euro. So we are talking about a total of about 4 billion euro invested in e-mobility in Romania until 2030. Just to compare, the modernization fund includes about 13 billion euro by 2030, of which 7 billion goes to investment in renewables. Another comparison the charging points, investments for charging points would be about 50% of the national expenditure for public roads, repair and maintenance. However, the investments, grid investments, I think they raise a problem because we get to about 80% of investments made by all distribution companies in Romania in 2020. In other words, if we take a linear approach, that would mean a 10% additional effort for them by 2030. If we look at renewables, to fuel these cars with renewables, that would mean that the ambitions should increase by 10%, about 600 megawatts. Altogether, all these investments, we estimated, would increase the share of electric cars in Romania from 0.15 now to somewhere 4% in 2030. Now, we should wonder whether this share is sufficient for the 2030 horizon, or whether we could come up with alternatives to e-mobility, maybe for fuel cells, but maybe we diversify other types of transport so that we move some of the burden from the individual transport. Thank you.
Da, o listă lungă de întrebări. Tu cred că faci parte din...
A very long list of questions. I think you are definitely among those who will provide answers. I would only say that I believe the essential problem is how we solve the problem, not if. We cannot afford the if question. We reached the end of some of the technologies awaiting for us in the next 10 years. We have Mr. Râmbu with us from ICPE, Head of Energy Department. His presentation will somehow sum up the green technology theory and probably will help us to transition to the next part. I hope you will bear with us 15 more minutes for the Q&A session. Hello, my name is Jimmy Râmbu. I represent another national research institute. We are present here, 2 research institutes at such a large round table with important companies. I will not get straight into my presentation. I would like to clarify a few things, maybe start from Mr. Tănăsescu's presentation. To be honest, after Professor Curaj's presentation, I felt honored to present. After Mr. Demetrescu, I felt somehow scared a bit. Why? Because Mr. Demetrescu somehow, well, it's not a reproach. I'm just trying to get a bit more interactive. Somehow, he sort of eliminated the research, the institutes, research institutes, and I don't want to confuse the audience. What do I mean?
Fiindcă după, eu știu, n-aș vrea să se creadă.
I wouldn't like the audience to believe, because here companies are talking about megawatts, and we, research institutes, are talking about kilowatts. Well, you should know that these kilowatts are important. And I should say that any energy system started from the watt and the kilowatt. And everything was further innovation to get to the megawatt. That meant the technological development of the initial innovation. So I would like to convince the audience after these speeches so that they don't believe that actually research is not important because we are only talking about kilowatts. And you see we have a fuel cell, electrolysis, and you could see what we could develop in institutes. We are talking about very low powers, but in general, we are talking about low powers, but this is innovation. And you need to understand that our role, research institutes, is not to develop the technology up to marketing the technology. This is what Siemens or any other big company is doing. They invest both in technological development, in marketing, in design. Our role is to develop and propose solutions. Maybe we can go up to the prototype level, and the prototype will be subject to technological transfer towards companies that take it further and market it.
De celule de combustibil, știți foarte bine, companiile în străinătate.
We are talking about fuel cells, and you know that companies have developed and implemented this in the market. We are talking about electrolyzers, but maybe you have different information. I don't know. I don't think in Romania we have fuel cell producers or electrolyzers producers or lithium-ion producers. There is one producer, a component of Rombat, I know of, and I would like to highlight here that the role of research institutes is to build the industry in Romania. This is why I emphasized that we do develop technology and then perform technology transfer to Romanian or foreign companies. About hydrogen, because the audience might be left with the impression that, okay, hydrogen is not good, why spend the energy? I want to tell you that the hydrogen, the discussions on hydrogen started, as far as I remember, or hydrogen is actually a storage solution first and foremost, and not necessarily a fuel. But this is where investment and development started, together with this massive discussion on hydrogen implementation. Because you might know, in Romania we've been producing hydrogen for quite a long time. We have large companies, Complex Borzești, for example, which is probably the largest hydrogen producer in Southeast Europe. But when we speak of hydrogen as a raw material in certain technological processes, then this is a goal with a primordial target, hydrogen production. But when we speak of the energy system and supporting the energy system with hydrogen implementation, then for us, hydrogen is a storage solution using electrolysis. For one system, 300 kilowatt power, we need to fill a field of 1 megawatt photovoltaic panels. You know, there are energy production systems in Romania, photovoltaic farms, wind farms, but there are areas which maybe do not enable the transfer of this massive quantity. So this could be a solution to produce locally and use those systems and produce hydrogen. And then, in these circumstances where you can't afford to take the energy and export it to the grid, then we have a storage solution. If we speak of e-mobility, if we all moved to e-cars now, this is impossible. But the hydrogen provides an alternative to electricity. But let's think of the current situation. As you could see, the energy problem, fuels, Russia, oil. Why don't decision makers say we need solutions? Tomorrow we no longer use oil, but we move to electricity. The goal is to increase the oil production. We forgot a bit the electric, and now there is pressure to increase the oil production. The focus should not be oil, but to find a new fuel. Not necessarily electric production systems, but a new fuel that can further support electric production. Then, we were talking, I would like to demonstrate how important 1 watt is. I'm a chemical engineer as my background, and since I graduated, I've been working in an electric engineering institute. When you speak to people in the field, obviously the discussions focus on megawatts. If I talk about a watt or a kilowatt, I am no longer interested in that discussion. However, if us as research institutes, if I as a researcher can tell you that I can give you technology to turn urine in electricity, will you be interested? Or if I say as a researcher that I am capable to train the microbes that would produce electricity, indeed they would produce milliwatts, not kilowatts. But if we speak of low power systems, low voltage systems, when we talk about LED lighting, megawatts are not relevant anymore. The low voltage microelectronics are working with watts or milliwatts. Then, if we think, let's add up all the technologies I told you about, the urine, the microbes producing electricity. And if we think, well, how can we bring together all these technologies?
Să facă împreună, să facem dezvoltare tehnică.
And then we go to Siemens, who can provide technological development. Do you think we can provide a solution for a localized unit which does not have access to electricity? I think then you would be interested in us in research and in milliwatts. I had the pleasure and the honor to work in a group in the UK where indeed we developed such projects, turning urine into electricity, and we developed green toilets. And this technology was implemented, for example, in Africa, in African areas where we provided light, electricity with energy storage for, I don't know, for poor areas.
După aceea, pe partea de...
Then, talking about energy storage, I'd like, for example, to remind you, because when I'm talking about storage, and my colleagues have showed you some other solutions, for example, the lithium-ion storage, this is not a viable energy storage, but in fact, the energy storage in lithium-ion was seen as a second life for lithium-ion batteries. We're not producing lithium-ion batteries for storage, but we're trying to reuse them to extend or to offer lithium-ion batteries a second life before reaching the dismantling and removal stage. Now, getting to getting to the actual presentation, I wanted first to address this energy storage topic and thermal energy storage. Now, I tried to find certain peculiarities for these technologies that would raise an interest in the future, because we all know about the solar, wind energy, geothermal energy. These are well-known solutions, but I tried to discuss about the current status and what else can be developed and what else can we do with these technologies. Because we all know that there are a lot of investments right now and a lot of focus in this area, which mainly talks about reducing costs, about understanding these technologies and trying to combine them and make them work together. Then we need to identify and see which is the role of the renewables in energy sustainability, and whether these technologies can influence one another or their development could influence one another. But again, technological development in renewables needs community support from the audience, but also from the private sector. Now, I listed here the technologies that I will be talking about. As I said, solar, wind, hydropower, geothermal energy. What else is interesting? For example, for the solar technologies, the silicate panels are well known, are well implemented. Now a trend is to eliminate, remove silicate, because it's a deficient raw material, and a trend is to develop a new generation of panels with increased performance and effectiveness. And the technological solutions that is currently studied is the introduction of new materials like perovskites, which are advantageous in terms of cost, in terms of processing, low temperature processing, but performance is still being studied. Then new solutions are being sought to implement photovoltaic systems, because we have this debate regarding agricultural land and implementation area, implementation site, and solutions are being sought to obtain floating solar panels in areas covered with lakes, for example. Then you're well aware of the fact that there are transparent photovoltaic panels or glasses to implement them on buildings. This is an interesting area and currently researched. These panels have the capacity to convert infrared radiation, but also visible light, into electricity. But they allow you to integrate these panels in a building, and the entire building facade would be turned into an energy producer. Now, the flexible solar cells are also an interesting solution, using semi-conducive inks that would offer an interesting perspective on these applications. Regarding wind technology, it would be interesting to develop offshore installations. And this offshore technology and using currents in that area would be an opportunity for transition to oil and gas industry. And I even found an article in Forbes from 2021 in which said that Shell purchased majority stake in the Emerald floating wind project in the Celtic Sea. So you can see how this technologies become interesting. The technological implementation part has an impact in our society, and we need these technologies and we need for society to accept these technologies, and we're working towards it, but also the cooperation of NGOs in such discussions would be useful. Regarding hydropower technology, it would be interesting to increase the flexibility of this technology, not necessarily in terms of large capacities, but even if we are developing small capacities that could be implemented on lakes or rivers, but at the same time allowing for technology development with a quick response regardless of the size. A new design is sought, changing the concept of turbines to allow for sea currents operation. I have some images here with some developments that we've designed in our institute, starting from low-capacity turbines of 10 kilowatts implemented on electrical sea crafts. We also have some projects related to exploiting tidal currents. Another concern of ours, it also had a European patent, is to change the design of a large turbine from a hydropower plant in order to allow the negative effects downstream determined by the reduction of the oxygen content and the marine life. Geothermal energy is also interesting, but there should be an increased interest in geothermal waters with medium to high temperatures, because using such geothermal waters you can produce electricity combining the electrical and thermal powers. But talking about such developments, we need to take into account materials, and if we have high temperatures, we have corrosions, we have erosion, so we have to find solutions. Then again, energy storage, as I said, hydrogen is storage solution and not necessarily an idea to produce it as a fuel. I discussed, and our colleague has shown how to store it in redox flow batteries. We also had projects in this regard. We analyzed vanadium and tried to increase energy effectiveness. Maybe we can discuss in the future and find other electrolytes than vanadium with high energy intensity based on ionic fluids or something else, or electrolysis, but always electrolysis should be accompanied by fuel cells, developing fuel cells, because we're producing hydrogen, but what we're doing with it, we have to be able to store it. So we also need to have an electrolyzer or components of electrolyzers, because some research institutes which have projects for fuel cells, the only ones were ICPE and ICSI. For ICPE, they even started these projects in the 60s when they made the first zinc ion cells. Unfortunately, the research was stopped because of some difficult conditions, but it was resumed after 2000. Then I'll talk about digitization and distributed generation. This is not my field of expertise, but it is a topic of interest. This was my presentation. Thank you, and I hope you will trust research. So we reached the end of the topics on the agenda. This should be the more interesting part of questions and answers. I hope you still have some interest and you're in a proper mood for this. I hope we all agree that when this is the case, we can accept, depending on each speaker's schedule, to leave this hall. Let's talk about innovation and how it can fundamentally change the logic of European competitiveness. I only want to make one comment. This is the conclusion of this report of the official position of the European Union about the green technology competitiveness, and the conclusion is that except wind, we're not in a competitive leading position in none of this technology, and this has also a positive side, that there are a lot of opportunities regarding technological innovation in renewables in Europe. I want to end here by thanking everyone in the audience and in the panel, and let's start with the questions that you may have. Please. I will start by thanking everyone for attending this conference today. I hope we managed to create this critical mass to stop the decline of research. We have an image about what was before 1989. We have some islands of creativity, like ICSI, like Nuclear Research Institute, but we still have still have a need for industry to join research. We have been working with our colleague Adrian Curaj to this topic for a number of years. There is a very hard work to be able to stop this decline. We discussed this topic with the Norwegian funds in Oslo. We are talking about smart cities. I don't want to disappoint you, but all forecasts regarding e-mobility in 2010 were not did not become a reality. We should have 1 to 10 charging stations in Romania, and we are much farther. We have 1.3 million electric cars in Romania, and in 2050 we should be green. This is a colossal effort. We have some very important challenges ahead of us. I said to Mr. Rushets that in 2015 in Sibiu he said what would be what about having a parking lot of 1,000 places with cars charging at the same time. This meant 25 megawatts, and everyone was appalled. They couldn't fathom such a project. We discuss in the advisory board in government, and we meet a lot of resistance to introduce standards at all levels, starting from the government. Using a procedure-based approach like we use in the nuclear field. So this is a large-scale effort. And I will stop here. Does anyone have any other questions, please? Regarding the last presentation, about those installations that you had in Africa, you said, to what extent this technology correlates to the hygiene conditions that they have there? So these installations, the bio batteries, if we can call them like this, transform urine in electricity, but at the same time they have the capacity to eliminate the bacteria from wastewater or from that area, so to clean that toilet of all bacteria. So this technology derives from using wastewater as green fuel for producing electricity. So you can use the bacteria. We used waters from treatment plant, and the bacteria become a biocatalyst which consume the organic matter. Any other questions, please? As far as I can see, there are no other questions. Probably this was a long day, a long forum, but I hope it was also very interesting. I only want to end it by saying that I am very optimistic, and I'm not known for this. I'm optimistic that Romania has a lot of intelligence, so that at least most of these challenges could be brought to technological standards that would bring us at least close to the targets that we have for 2030. And I will close with the idea that a debate on how to reach the targets would be essential rather than a debate about the targets, which is most prevalent only 3 years from the moment when these targets were agreed. So I want to close this meeting by thanking all of you in the panel and in the audience for having the patience to listen to us, and I wish you all a safe travel to your homes. Thank you.